Alright, so let's start off with some of the basic features and shortcuts.
That was like 5 scoops!
Hey, you! On the sofa! Are you a lazy waste of space? Then you need the new Game Thing! Simply go to GameThing.com, put in the letters of your name, and wait 5 to 7 business days for the Game Thing to arrive. So buy now or you're lame! Obfuscate residence. You're dumb! You spelt your name very wrong! Your ad just said to put in the letters of my name. It didn't say anything about it being in order. Well, guess what, idiot? You're not getting the Game Thing! She just said to write the letters of my name. And I did! It's common intuition, at least for most people, that stuff that is simple is also very easy. And that common intuition is very, very wrong. Thue is an esoteric programming language that is so wonderful that on solangs.org, it has been the featured language for well over a year. For those curious about the previous featured languages, Fukitan was featured for a couple months beforehand, and Brainfuck was featured before that for about 6 years. It doesn't seem like they update that very often. Thue is based off of something called Semi-Thue grammar, which itself was named after this guy named Axel Thue. And yes, Thue is pronounced differently from Thue because the manual says so. So basically, Thue is based off of taking strings and replacing them with other strings. Programs in Thue are made up of several building blocks called substitutions, which are set up like this. Probably because : equals will never be used in a regular string. When the string on the left is found in the initial program state, it is replaced with the string on the right. The list of substitutions ends with : equals by itself with nothing on the left or right. What follows that is the initial program state. And that's basically all the rules of Thue. Once the program is run, the substitutions are applied to the initial program state. Once no more substitutions can be performed, the program stops running. So in this example, cat is replaced letter by letter until it becomes the word dog. Now you may be thinking, that's just slashes but written differently. And I can see why you would think that. Both slashes and Thue are based off of rewriting strings. In Thue, however, the string replacement occurs randomly. It doesn't matter how you arrange the replacements in Thue, since they are chosen at random from what the program state allows. If we run the cat to dog program again, but do it step by step, you can see that it replaces the letters in a random order that is completely different every time. If we make the program output those letters to the console by preceding the replacement with a tilde, we get an anagram of dog that is different every time. The Hello World program in Thue looks like this. It takes the @ symbol and replaces it with outputting Hello World, and the initial program state is an @ symbol. Pretty simple, really. The Truth Machine program is slightly more interesting. The initial program state is the letter A between 2 dashes. The letter A is replaced by the user's input using this special case, where 3 colons represent the user's input. The sequence of -0 is replaced with outputting a 0, while the sequence of 1 without the dashes outputs a 1. Finally, if the sequence -- is found, 1 is inserted in like this. If this happens, it goes into a loop and outputs 1 forever. Lame! That was a program taken from solangs.org. Moving on, here's a program that is a modified form of the Truth Machine that shows Thue's randomness. Rather than A being replaced by your input, it is replaced with outputting a randomly chosen letter. I call this program the Shakespeare Outputter because, given enough time, it will probably maybe possibly output a copy of a Shakespeare play.
What, you egg?
He stabs him. Anyway, now let's do some fun mathy things in Thue.
Math in Thue? How? It doesn't have the ability to use numbers.
Numbers? Where we're going, we don't need numbers. Thue, like most string rewriting solangs, thrives with the Unary System, which is basically just a fancy way of saying we use a bunch of asterisks to do math that you need to manually count. Here's a doubling program. It starts by replacing the letter A with the input, taken as unary. For example, let's say the input's 3. Next, an angle bracket followed by an asterisk is replaced with 2 C's, followed by the angle bracket. This will cause the angle bracket to move along the asterisks, producing 2 C's for each asterisk. When it reaches the closing bracket, the brackets are removed. At this point, we have a number of C's corresponding to the input times 2, so we output them as asterisks.
Well, multiplying by 2 is nice, but what if I want to multiply by something other than 2? Like 4.
Well, use the general multiplication program. It takes in 2 numbers, big A and big B, and multiplies them. Using the bracketing system from the previous program, both terms are first converted to little a's and little b's.
Well, that's a cool way to separate terms, but how do we get multiplication from this?
Well, we move all the a's to the right side and all the b's to the left side, and we do this by swapping them. To finish that task, it will always need to perform a times b swaps. So each swap adds in an exclamation point, which is then outputted as an asterisk. This lets us count the swaps. And now we have unary multiplication.
Well, I just multiplied 100 by 100, and I'm having a hard time counting all of these. How do I make it more readable?
Well, you can use the Roman numeral conversion program. Because of the randomness of 2a, a simple replace this with this Roman numerals program like this one won't work. So I made this one. It forces each letter to convert its highest value from left to right, and when I reaches the semicolon, it goes back and removes all the smaller letters and leaves us with just a Roman numeral as the program state. It also leaves us with a semicolon, but we're gonna pretend it's not there. Hold on, what's that line of dashes for? Oh, that's just to add some extra buffer between the actual asterisks and finalizing the numeral. So because the dashes are here, it's very unlikely that the semicolon will erase the small letters before the full numeral is made. Isn't that solution extremely terrible? Yes! But I'm not fixing it because it works pretty much almost always. Anyway, if you want to try out 2a yourself, a link is in the description. Thanks for watching, and I'll see you next time!